Swayam Prabha. Digital India. Educated India.
Hello, welcome everyone. I am Devabrata Maiti from IIT Bombay. I would like to welcome all of you for this course Organometallic Chemistry 1. In this course we have decided to discuss mainly about the synthetic aspects of organometallic chemistry. This will be both for inorganic chemists and organic chemists as well. I am sure most of you have taken some courses in organometallic chemistry so far, and you have been introduced to this topic before. Nonetheless, there are some prerequisites for this course which I will briefly outline, but major aspect we will try to focus in this 10-hour course is the fundamentals of organometallic chemistry. What is the basis of different reactions of organometallic chemistry? Often we see both in textbook or in industry a number of reactions going on, a number of catalysis is going on, and by looking at the transformation we just simply gets mesmerized how that reaction might be possible. Okay. So this is the beauty of organometallic chemistry, seemingly difficult reaction which is otherwise not possible by, let's say, traditional organic or inorganic type of reaction. Organometallic chemistry can do wonder. So therefore, knowing different varieties of organometallic reactions will be of fundamental and as well as very synthetic importance. As you know, organometallic chemistry in often it is discussed in the way that it is the metal carbon bond formation reaction, or if a compound is having metal carbon bond, that is loosely defined as the organometallic compound, or the chemistry derived from it is classically defined as organometallic chemistry. But there exists nowadays, we don't really restrict the term organometallic chemistry to this basic definition. We also use various non-metal or semi-metal species and their carbon complexes also under the banner of organometallic chemistry, and actually there are number of examples with boron, silicon, phosphorus, arsenic for example, to discuss about their carbon complexes as or these metal or non-metal and or metal semi-metal carbon complexes as the organometallic species. So it all actually derives from the fact that the electronegativity difference between the, let's say, metal and the carbon centers. Now, without going into too much of the history of organometallic chemistry and what organometallic chemist has done so far, we'll try to focus mainly discussing about what organometallic chemistry can do. What are the type of reactions we are going to see. Okay. So the prerequisite for this course, I would like to point out that one should learn before getting into the discussion of this course. People should know about the historical background that is essential. Since it's a 10-hour course, we will try to restrict on that. And of course, different features of organometallic chemistry, these are the things one is expected to know, and oxidation states, fundamental to learn any chemistry, oxidation states as well as periodic trend. This is hopefully all of you are familiar with, and you can refresh your memory with these, and of course d orbitals, electron count and heptacity, of course d orbitals, heptacity, is it a back bonding? These are of course another famous topic of organometallic chemistry as such, back bonding, and knowing the properties of alkene, alkynes, all will be useful. Alkenes, alkynes, all these things one is expected to, of course, phosphine ligand are always going to be useful. So, these are the things I expect all of you are familiar with, or you can refresh your memory a little bit, learn a little bit about more about the periodic table, periodic trend, and a little bit about the electronic configuration of each and every metal. That will be very, very important, because whenever you will be counting the electron for a given complex, those will be useful. The valence electron mainly like you to get an idea about, and of course the oxidation state and periodic trend and different carbon monoxide, alkyne, olefin, their electronic configuration and everything one is expected to know. Okay. Without dwelling too much on that, I think I will take you to the syllabus, what we will be discussing for this course. For this course, before getting into the syllabus, there exist a number of books, and quite helpful for this organometallic chemistry. One is expected to learn. Of course, my learning has been influenced by various teachers which I have come across during my bachelor's, master's, PhD and postdoc studies. But essentially there are a number of books which you are certainly encouraged to read about. Any books should be okay to so to speak in terms of the fundamental of the chemistry that we will be discussing, but mainly I would say the basics of organometallic chemistry, by Anil J. Elias, that's our colleague at IIT Delhi. Of course, the other fundamental books include Crabtree's Organometallic Chemistry and Elsten-Broich, as well as a very excellent book by John Hartwig. These are the books one can consult. Other than that, I think any other book of organometallic chemistry can also be consulted, or I hope if you try to focus on this course and pick up any other book, that should be good enough for this activity. Now mainly we'll try to outline the syllabus of this course. Okay. For this purpose, we would like to usually go one topic at a time on a half an hour class basis. So although it's like a total 10-hour course, so definitely there will be divided into 20 classes, so 20 small classes. Each class roughly will discuss one topic. Sometime it will spill over to another class, but most often in a half an hour slot we will try to discuss one topic, sometime two topics. Very rarely we will discuss one topic into the two half-an-hour courses if the topic happen to be little bit of more importance and we need to discuss more about it. Okay. So let's look at the syllabus roughly. Well, we will start, as almost every chemist need to discuss, the 18 electron rules. Briefly we will discuss that. Okay. 18 electron rules, I'm expecting you are familiar with, but we will just try to discuss electron count of it and electron count of the organometallic complexes, and try to give some example and then move on from the topic. The major focus from there on will be the ligand substitution reactions. Okay. These are of two types. One will be on associative mechanism, another will be the dissociative one. Okay. This is the first topic, major topic we will be focusing, ligand substitution reactions, followed by one of the most important topic will be the oxidative addition, with plenty of example. Always we will be discussing each and every topic with plenty of example. Oxidative addition, these examples again are influenced by my previous exposure or from different books and so on. So these are going to be concerted mechanism oxidative addition. There are 3 different mechanism. It will be so concerted, SN2 and the radical mechanism. These 3 different mechanisms will be discussed. Of course, almost the microscopic reverse of oxidative addition will be the reductive elimination, which is again although it is microscopic reverse, still we need to discuss quite efficiently on these. Elimination. Okay. Moving on further from this, we will be discussing the migratory aptitude, migratory insertion and elimination reaction. There would be alpha and beta migratory insertion and elimination. So the next topic will be the migratory insertion and elimination reactions and elimination. So here we will be discussing alpha, of course alpha migratory insertion, alpha migratory elimination, and of course beta migratory insertion, beta migratory elimination, and we will also discuss quite a lot about the example of it, and a lot of example where we will combine both the beta migratory insertion and beta elimination reactions. Subsequently, we will move to alpha abstraction and beta abstraction reactions, and finally moving further to 4 center reactions, 2+2 reactions. These are various type of reaction pattern we will be discussing, and attack by external ligand. So when let's say for example we have we have an olefin and then we would like to interact with this metal center, so that is the external ligand attack, and then of course the reductive coupling. These are the topic mainly we will be discussing. Now of course some of these topic you may have heard of. We'll try to discuss each and every topic in greater detail. Once again, almost each of these topic will be discussed in half an hour time scale. So roughly I think 1, 2, 3, 4, 5, 6 and nearly 10 topics will be discussed, and each topic may be having 2 subtopics. So one topic will have nearly 1 hour of discussion. Each subtopic, if we are having 2 subtopic or under one topic, we might will discuss half an hour each on those. Okay. Of course, after learning all these reaction pattern or reactivity pattern, we then must apply some of these pattern, some of these reaction types to a generalized reaction scheme, so to speak, one of the catalytic cycle. Subsequently, we would like to discuss, let's say mainly we will try to focus or we will try to restrict ourselves to the hydrogenation reaction and carbonylation reaction, and try to see how some of these reaction types or protocols can be applied to the catalytic cycle. Usually, as you know, a catalytic cycle will have multiple steps, right? So maybe having, let's say 4 steps, 5 steps and so on. Now each of these 4 steps is necessarily covered by all these 10 topics or total 20 different subtopics we are talking about. Each of the catalytic cycle can be broken down into these topics or subtopics. Okay. So therefore, by knowing these topics, we should be able to discuss about any catalytic cycle with confidence, and we'll be able to understand the mechanism in details. That's, I guess, will be the strongest point of this organometallic chemistry 1. So once again, we'll be discussing the ligand substitution reaction to start with. We'll have the associative and dissociative mechanism, how the ligand substitution reaction occurs. At the beginning, you have a organometallic compounds. Of course, the organometallic compound you are going to have is going to be usually stable one. You need to do some chemistry with it. Therefore, you need to undergo a ligand dissociation or association reaction, right? If it is an 18 electron species, for example, you need to lose one ligand to make it 16 electrons, so that the metal will encourage for an exogenous substrate. otherwise 18 electron species complex will not be really feeling that much encouraged to undergo any reaction, right. So ligand substitution reaction, how it occurs, associative mechanism and dissociative mechanism we will be discussing. Subsequently we will discuss the oxidative addition. Again, this is one of the topics which is quite popular. Oxidative addition usually reminds us about like insertion into the carbon bromine bond of the bromobenzene, for example, by a organometallic species, let's say for example palladium, and then we get a palladium 0 oxidation state to palladium 2+ oxidation state, right, and where we have a aryl carbon metal bond along with metal bromide bonds, right. So these oxidative addition reaction can be of different type. It could be concerted mechanism, it could be SN2 mechanism, of course it can be of radical type in nature, right. So the different types of oxidative addition we will discuss. Subsequently you would like to see the reductive elimination, which is the opposite of it. So imagine two partners are on one metal, and then we want to take out those two partners and combine those two partners together, and then leaving a lot of vacant site to the metal center. Those will be again essential for often regenerating the catalyst or making the catalyst more effective. Okay. As we go along, we will see how the migratory insertion is occurring, how you have one group with the metal center, and then that group is trying to migrate on the another group such as olefin or other unsaturated partner which is associated with the metal center. Now we can have various type of reaction from that angle. We can have alpha migratory insertion. So at the alpha position of that olefin or let's say carbonyl, we will be migrating another group which is associated with the metal center. Then also we can have the insertion or elimination from the beta position of the ligated coupling, ligated partner on the metal center. Of course, another variation of such type of reaction will be the abstraction. This abstraction could be similar in a way. It is essentially going to be similar compared to your migratory insertion or elimination reaction. So alpha abstraction and the beta abstraction will be similar to the alpha migratory elimination or beta migratory elimination, but fundamentally these are different type of reaction that we will see the difference. In lot of cases we may not be having an opportunity to let's say undergo traditional oxidative addition or traditional reductive elimination reactions. So what will then have in those particular cases we might will have an opportunity to go about the 4-center reaction mechanism, right. So that is also essential when we need that, what are the major type of reaction, and when we cannot have those major type of reaction but an alternative has to be looked up. Similarly, like alpha and beta migratory insertion and elimination, when we talk about those are the major one, but when the abstraction reaction predominant, that also need to be looked at. Others will be of course the 2+2 reactions, where two unsaturated unit will be coupling together, so called famous reactions we have seen like metathesis reaction, how these reaction occurs, what is the basic or fundamental outlying principle for this reaction we would like to also discuss. Then simple, if you take let's say simple olefin, you want to react it with a nucleophile, you may not be getting such any reaction, but that olefin if you want to interact with the metal center, then you might will have an opportunity to react the nucleophile with the olefin. This is another class of reaction, external attack by a nucleophile to the olefinic center. Subsequently, of course, we would also like to discuss the reductive coupling, which is again another fundamental class of reactions. So these are the major type of reaction we will be discussing in depth, in detail regarding this course. After discussing this, we will be discussing the hydrogenation reactions and the carbonylation reaction. In terms of hydrogenation catalyst, we will have two types of catalyst. One is monohydride catalyst and the other will be the dihydride catalyst. How fundamentally these two catalysts are different, what are the steps to undergo the to understand the hydrogenation reactions, that we will be trying to discuss. Mainly you will see usually it's a ligand association dissociation reaction, then of course the oxidative addition or olefin coordination, subsequent oxidative addition, insertion, and then reductive elimination reaction to give you the product. These are going to be the simplest reaction of all. Finally, we will move on for this course to the carbonylation, where we would like to look at quite a lot of topics such as hydroformylation reaction, of course Monsanto acetic acid process, where we will be discussing about the methanol getting converted into the carboxylic acid, and in the hydroformylation reaction we will be discussing olefin reacting with the carbon monoxide and hydrogen mixture to give you the aldehyde. This aldehyde can be of two different types. It could be the terminal aldehyde, it could be the branch one as well, and subsequently we will be discussing the hydrocarboxylation reaction, and we will cap up the discussion by having the hydrocyanation reaction, hydrocyanation of olefin. We also would like to touch upon just little bit on the asymmetric version of these reactions. Okay. We may not be able to discuss, due to the interest of time, way too much about the asymmetric reaction, but whenever possible, whenever an asymmetric version of the catalysis will be possible, we will be discussing briefly. So that will be also discussed in this fundamental type of reaction like oxidative addition, reductive elimination, and other type of reaction where whenever there is a scope of discussing the asymmetric catalysis or asymmetric centered, how fundamentally it will be dealt with by a reaction type, also be discussed during this course. Okay. So welcome again. So we will total again, including this one, we will have total 10 hours discussion, and I would like you to ask as many questions as possible after each and every section, and of course there will be some evaluation as one could expect for these courses. Along with it, we will try to see if your understanding can be broadened. If you have any queries, please feel free to ask me. Okay. So in the next class, mainly we will try to discuss the 18 electron rule, and from there on various ligand substitution reaction we will be focusing on. Okay. So this will be all for the introductory part of this course, and feel free to drop me any queries that you may be having regarding the course. Thank you.
SwayamPrabha. Digital India. Educated India.